Dear students, in this video, I am going to discuss some of the objective questions from second level, level 2 of our Haloalkanes, Haloarenes NEET examination related questions. First level we have finished in the first lecture, and second level we are going to discuss about some of the doubts which have you got in difficult questions or different type of questions what you have issued to me, that I will discuss in this second lecture of Haloalkanes, Haloarenes, getting ready for 2024. Okay, let us discuss about that questions. So, dear students, there was a question we have in front of us, that is nothing but yes. Yeah. First, we will see a question based on a small general physical property of the question. That is question. Tertiary alkyl halide among the following. The question is tertiary alkyl halide among the following is we have options 2-chloro-butane and also secondary butyl chloride, secondary butyl chloride, another one isobutyl chloride, and the fourth one 3-chloro 3-methyl 3-chloro 3-methyl pentane. Okay, let us see that. Dear students, whenever the question is given like that, you must remember that what kind of answer should be given to this correctly. Representation of the structures is most important. 2-chlorobutane means there are 4 chlorines are there, and second chlorine we have second carbon we have chlorine is there. So it is secondary. Secondary butyl chloride. So this is also the same only. It is secondary butyl chloride. Isobutyl chloride. Isobutyl is this one. Isobutyl chloride is nothing but these 2 chlorines are there, and it is a isobutyl chloride which is 1-chloro, and the first carbon chlorine is there, whereas secondary butyl chloride is there. The secondary butyl chloride, if you want to just observe, the secondary butyl chloride is nothing but there are 4 chlorines are there. this one, both are same only. Both are same. That is secondary butyl chloride. Let us see the third one, 3-chloro-3-methyl pentane. 3-chloro-3-methyl pentane means pent means we have five carbons are there. On the third carbon we have chlorine. On the third carbon we have methyl is there. So this is tertiary. So from this discussion, 3-chloro-3-methyl pentane is the right answer for this question. Okay. Let us see the next one. Another question we will see from this level 2. Question number 2. That is C2H5Cl plus Na gives rise to A. And on the arrow mark they are given dry ether, and they removed NaCl also from this to get A. A on monochlorination, they're telling it gives how many isomers? The question is how many isomers? We have options 1, 2, third option 3, fourth option 4. These are the options we have. Okay. We will see this equation. Actually, this equation is Wood's reaction. So 2 moles of C2H5Cl if you take with 2 moles of Na, only you will get that C4H10 N-butane with the removal of 2 moles of NaCl in the presence of dry ether. The point is, this C4H10 we can write like this. Okay. The remaining parts are hydrogens only. The question they are asking is monochlorination. Monochlorination is possible on every carbon we have. So this carbon and this carbon and this carbon. Monochlorination. So if you just do monochlorination, then what are the possibilities of getting the products? If you just see, the possibilities of getting products will be like this. That may give N-butyl chloride. That will give isobutyl chloride. That will give what we call secondary butyl chloride, that will give tertiary butyl chloride. So on these three, seeing these three, how many possibilities are there? There are 4 possibilities are there we have. So 4 is the right answer for this question. Okay, let us see the question number 3. Another question we will see on this, that is, the question is, we have CH3Br, that is methyl bromide, in the presence treated with magnesium in the presence of ether, has given X. And again that X is treated with the presence of tertiary butyl alcohol, that is CH3 thrice COH, and that has given a product A. What is the product? What is the product A is? We have options. CH4 is there. CH3 thrice CH is there. And third one, we have CH3 thrice COBr is there. Fourth one, CH3 thrice COCH3 is there. See, dear students, whenever this type of challenge is there in front of us, what we have to do is we have to solve this all conversions. First one, if you observe, the methyl bromide treated with magnesium in the presence of ether, generally it will give methyl magnesium bromide, CH3MgBr, nothing but Grignard reagent. This is X. Further reaction, if you just see the Grignard reagent with tertiary butyl alcohol, that is CH3 thrice COH, tertiary butyl alcohol with the Grignard reagent CH3 MgBr. So to get a product, we need to continue up to hydrolysis, okay, acid hydrolysis. But Grignard reagent, how it splits means it splits into CH3 minus and Mg plus. At the same time, the tertiary butyl alcohol is said to be splits into alkoxide and H plus. That means alkoxide is separated out as a nucleophile. Then the CH3 will attach to H plus. So CH3 and H to give CH4 plus. The byproduct is Mg OCCH3 thrice X. So in this reaction, we understand that CH4 is the major product. So methane is the right answer for this question. Okay. Let us see the next question you have discussed. The question is 2-chloro 1-phenyl 2-chloro 1-phenyl propane 2-chloro 1-methyl propane when treated with alcoholic KOH gives dash as the major product, So we have options are there, that is 1-phenyl propene 1, we have 3-phenyl propene 1, 3-phenyl propene 1. Another one we have 1-phenyl 2-propanol 1-phenyl 2-propanol The last one, 3-phenyl 1-propanol. 3-phenyl 1-propanol. Seeing this question, we can understand the question which they are discussing is nothing but with alcoholic KOH, what will happen about the haloalkane? Usually, alcohol KOH is said to be one of the dehydrohalogenating agent, which gives alkanes after the reaction. That means alkanes will be the products. See this alkene product information. 2-chloro 1-phenyl propane means we have 3 carbons are there in propane. On the second carbon we have chlorine is there. On the first carbon we have phenyl is there. On the first carbon we have phenyl is there. Phenyl is nothing but pH. Okay. So the hydrogen will be removed from this what we call adjacent carbons. So if you take this one, adjacent carbon, this in the presence of alcoholic KOH, the beta elimination takes place, and which allows the more substituted alkene. That means highly substituted alkene will be formed when we remove the carbon from phenyl attached carbon. We will remove hydrogen from phenyl attached carbon. So if you remove hydrogen here, and the product will be pH, CH, pH, CH, double bond, CH, CH3 will come. So what do you mean by this one is nothing but, if you give numbering here, this is first one, this is second one, this is third one. On the first one we have phenyl is there. That means it is 1-phenyl, substituent is phenyl, and functional group is alkane, propane, prop-1-ene or propane 1. So 1-phenyl propane 1 is the right answer for this question. Let us see the another question. Question number 5. We have been given C2H4, and C2H4 is said to be treated with HCl in the presence of anhydrous AlCl3. So AlCl3, that is given a product A, and that A is further treated in 2 different ways. The one method is reaction with aqueous ethanolic AgNO3, KCN. Another one is aqueous ethanolic AgCN. We got the products C and B and D. Okay, C and D, assume C and D. Okay, so they are given like this. Then what is the question is the covalence of carbon, in the functional group of C, and D are, we have options 3, 3, 4, 4, 4, 3. And the fourth option we have 3, 4. So this is the question we have in front of us. See, dear students, first of all, we need to understand what is A. You know that C2H4 alkene undergoes addition reaction. HCl gives C2H5 Cl. Ethyl chloride is the product in the first reaction. So A is ethyl chloride. If that ethyl chloride is treated C2H5Cl with KCN, aqueous KCN, aqueous ethanolic KCN, you will get C2H5CN. CN is the function group in the C. So in the C, CN is the function group. So carbon with nitrogen, we have triple bond is existed. This carbon covalence is 4. So 4 is the covalence of this cyanide carbon in the functional group present in C. See the other equation, C2H5Cl plus aqueous ethanolic AgCN. If you take AgCN is predominantly covalent and this will give C2H5NC, that is D. NC is nothing but isocyanide where nitrogen and carbon linked by a triple bond, but carbon is having 3 bonds only. So it is 3 is the covalence of carbon in isocyanide. So after observing these things, you can understand that 4 is the covalence of carbon in the cyanide and 3 is the covalence of carbon in isocyanide. 4, 3 is the right option for this question. Okay, dear students, whichever the questions asked like this, in these questions, we'll be having a different idea. Like these are all equation based on the chemical reaction based, chemical preparation based questions from that. Similarly, once we see a general equation, an equation asked in a question, we have C2H5Cl if you take excess. C2H5Cl if you take excess. And that is treated with NH3. NH3 is nothing but ammonia alcoholic condition, and that is given finally A. A is the final product. A is the final product. Asking what is the covalence of N in A? Covalence of N in A. What is N? N's covalence in product A. For this, we need to understand one thing. Yeah, there are options are there with us. 4, 3, and 2, and fourth option is 1. Assume this is sixth question. In this question, C2H5Cl taken as excess. Whenever excess alkyl halide is taken, you can understand that this C2H5Cl treated with ammonia in this reaction, C2H5Cl plus ammonia can be written as HNH2, and that produces C2H5 NH2. So we have removed HCl from this reaction. We got primary amine. We got primary amine in this one. If you continue to do like this, that means C2H5 NH2 again will be treated with ethyl chloride, chloroethane, C2H5Cl. Second step, after removal of HCl, you will get C2H5 twice NH, which is called as secondary amine. Secondary amine. Further, we can take, why? Because it will give secondary, tertiary, quaternary ammonium salts. So C2H5 twice NH, if it is treated with ethyl chloride, in the third step, removal of HCl, we will get C2H5 thrice N. That is called tertiary amine. Tertiary amine. And that tertiary amine C2H5 thrice N is finally treated with C2H5Cl, gives quaternary ammonium salt, means C2H5 4 times N plus and Cl minus. Ammonium is the salt is the final product, that is A. A is the final product as per the question. So as per the question, what is the final product is A. That means around nitrogen, there are 4 bonds are there with alkyl groups. That 4 is the covalence for this one present in the fourth equation we have. That means 4 is the covalence. First option is the right option for this question. Okay, dear students. So in this video, we have observed some interesting questions from level 2 of IL series by YRK'S Smart Lab channel. Okay. Hope you understand this one. We'll continue with this type of discussions in the coming classes also. Until have a nice day. Thank you very much.